All right. Hey, what's going on, everybody? So we are back here at the code review. This time we're going to actually do some perusing of code. Look around, check it out, look at some stuff, look at some code, see what we get. So we got let me see. Let me just check a little something here, guys. Let's check a little something. So we're going to be perusing code. Nothing wrong with having a little bit of a chillaxing. Mm, mm. Let's see. All right, everybody. So, yeah. So, anyways, so let's see what do we got here. So we got Linux. We're gonna be checking out Linux. We're gonna be looking at some Linux code. Um, oh, let's see what we got here. So this is kind of interesting. I've never actually visited this repository before. Um, and so look at this. We have. I did. I mean, I thought there was more stars than this. I mean, I don't know how long this repository has been around. I'm kind of curious to actually check that out to see how long the repository itself has been around. But 1.4 million commits. That's a hell of a lot of that's a hell of a lot of commits, no? I mean, yeah. And then a little over 236,000 stars. I mean, I expected more than that. Forking, a lot of forking. There's been a hell of a lot of forking here. A lot of forking in all kind of different ways. Dirty little forking. All right, forking. All right, cool. People they're watching it. There's a lot of watchers, a lot of eyeballs every damn where. Multiply that by two, then divide. All right, cool. So anyway, so what else do we got? We got contributors. We got 18,341 contributors on this model. Whoa. Okay. Okay. Well, that's not bad. Not too bloody shabby, now. Yeah. Not too shabby. Not too shabby. Not too. Okay. Okay. Anyway. So I already downloaded this thing. It's a couple of thousand couple. I mean, it's a couple of megs. All right. It's about altogether. I think when I unzipped it, is about 1.3 gigs, something like that. So I'm like, okay, 1.3 gigs. All right, cool. So I'm just looking around here. So here this is the README. Um, yeah, so Linux kernel is the core of the Linux operating system. It manages hardware, system resources, and provides the fundamental services for all other software in the world. No, I mean, well, you know what I mean. For all this other software running on the system. Oh, okay. So this is cool. Yeah. So okay. So what do we got? So it's quick stuff here. So we got some essential documentation. Let me see. All users should be familiar with building requirements. Oh snap! You got to get familiar with these requirements. Codes of conduct. Right? You got to be nice. Don't be nasty. Don't be nasty. All right. See, find your role below. Let's see what kind of role we got here. Kernel developer. All right. All right. Um. What is that? We got kernel developer. Oh, let's turn this down just a little bit. Kernel developer. What else we got here? We got academic researcher. Right. Security expert. All right. No. Backport performance system administrator, maintainer, hardware vendor, AI coding assistant. Oh, word. Okay. And then you got descriptions of each one, I suppose. I don't know. I guess documentations of where to start and all that crap. Oh, that's pretty cool. Pretty interesting. All right. So it tells you where you should start out at if you're going to Oh well, I should probably get some more. Oh, cool. Whoa. We got all kinds of Let's just get, low key background music. I don't know. So yeah, so well, security experts. All right, so a lot of little, areas here. They point you in various areas of documentation if, depending upon your role. I would think there's more roles though than just this, but maybe there is, maybe there's not. Anyway, so we got most of it is in C. So you got a lot of, 98% C, right? Assembly, right. So you got point whatever. Assembly is the next. Then you got some, right, shell stuff going on there, right? So and then you got some Python, and that's interesting. So I wonder what the other is. Very curious about that. I didn't know we had any Rust in there. That I didn't know. It's rusty, a little rustiness. I wonder what flavor of assembly. Um, hmm, curiousness. All right, no C++, no C++, or maybe that's where the other is at. But I would think they'd mention C++ if it was there, Right? So, so clearly, we're strongly biased towards C, which is why I have the modern. Why, I have this publication here from this wonderful vendor, called, Manning. Perhaps you've heard of him. I don't know. All right. So anyway, I mean, I think it's a pretty good book. Whether or not it'll actually help me to actually decipher what's going on inside the code base, I don't know. Code base has probably been around for a while, I think. This book right here discusses modern C. So what I don't know if the code is modernized or what. I don't know. So anyway, we're gonna find out. And let's see what we got here. Let's get some different music. This is like, oh well, let's yeah, I like that, like that. You get a little time. That yeah, so anyway, so that's cool. So Manning has a lot of good publications, pretty awesome. I mean, that's why I usually go, they're my like go to org, I'm not getting paid by Manning for this video. Nothing like that. All right, so anyway, so like I said, I downloaded the code. Oh crap, man. Downloaded the code, right? So it's already open on my machine here. This is what it looks like. It's a couple of, it's about 1.0, I don't know, 1.4 gigs. All right. Um, so let's see what we got. Let's see what we can do, guys. Let's see what we can crack open in here. Well, first thing we're gonna crack open, we already cracked open the README. We already saw that, but README is a README. You gotta read me. Maybe the AI might help us. The AI might help us decipher. Where do we start? All right. Well, I don't know. Who the hell knows? Anyway, so let's see. Do we want to go into the tools? What do we got? We got architecture. Architecture. Oh, okay. So this is hardware. Hardware. This is probably hardware code, something like that. We got blocks here. Hmm. All right. This is interesting. All right. Hmm. Partitions. Okay. Quite a bit of code here, folks. Quite a bit of code. Hmm. Okay. Certs, I assume that has something to do with security. I would have sort of thought maybe we'd have readmes inside of each one of these little directories. But there's a documentation directory, so that might. Oh, yeah, that's not bad. So you probably have documentation for each directory. Okay, see now that's not bad. I didn't know that. I didn't know that. That's cool. All right. So we have stuff crypto. So it probably has something to do with encryption, right? Encryption code, right? Mm-hmm. Right? Hacker, huh? We're gonna encrypt. We're gonna hack. We're gonna hack. We're gonna encrypt. Huh? Yeah. Let's see here. Drivers, right? Driving Miss Daisy, driving around. Huh? Okay. So drive. We already know what drivers are, but I guess that. I mean, I would think it has something to do with hardware and all that stuff. This is accessibility. Okay. Braille. Okay. Well, Braille console. Well, now that's kind of interesting. So it has support for a Braille console. What the hell? I mean, that's cool. I'm just like, okay, well, that's interesting. Okay. What does that mean though? So we have the context. See, that's kind of interesting that we have a context. So this is obviously something to do with sound, right? Beepy beepy. Has a couple of things to do with hertz and whatnot. That's interesting. That's cool. We have some pound defines up in here defining constants. All right, we got a couple of static variables here, buffers and whatnot. Ski. All right, all right, all right. Oh, here we go. Braille write. So I wonder what does that mean, Braille write. So I wonder if that means that we're actually gonna like, maybe there's like some sort of Braille surface area or something like that, and then basically let me turn down. You know what love is. Anyway, so yeah, so I mean, right? So yeah, I don't really know, but we got the context of the code, so that's it's pretty interesting. Pretty interesting stuff here. We got something that we're last write. We're writing stuff, but we're writing to some sort of braille-oriented thing. Ah, okay. So there you go. So what does this mean? So let's go ahead and well, we're gonna find out. We're gonna ask the mighty Googles. All right. Wake up in the morning and find. Oh, what is this? Some sort of medical facility. Ah, okay. Medical technical facilities. All right. Okay. Visio Braille. Mm, okay. Let's take a look. Let's get some more. Let's give it let me see. PC. Okay. Maybe is it just software? No, manufacturer ergonomic refreshable braille displays. Okay, well there we go. So refreshable braille. I've never. I guess I've never. That's interesting. Screen reader compatibility, Bluetooth, and all that. Okay, so we got something a braille display. I'm curious as to what that looks like because I've never actually thought about what. Okay, wow. I wonder if you guys knew about that. Okay, that's that. Now that is interesting. I've never. Let me see the compact uncomplicated braille display just plugged in. So I know what braille is, but I'm wondering, does this actually change, like based on words, like dynamically? That would be pretty. Oh, look at that. Okay, let's check it out. So, is a high quality yet affordable 40 cell braille display for computer users that need. So that's interesting. So I guess, because braille, I understand for people that are blind, they touch it. So I wonder if this actually changes dynamically. I'm very curious as to see whether or not how that tech works. That is very cool and very interesting. I mean, does it morph? Get out of here. Um, okay. Well, anyway, so that's a whole different kind of video there, but that's very cool and very interesting that Linux has that built up into it. Some support for a Braille device, and clearly it's doing something here. It's doing, we're up in here, we're up in this function. This is a function particularly for that device, I assume. And so, it gets some sort of input, goes into the buffer. The buffer then, does it perform a mem copy, right? And as a result of that mem copy, then we're going to decipher some stuff, some things here, right? We're doing some deciphering, right? Because we're going ahead, and it has a particular width, and we're just going to step through our buffer. This is going to be the output, right? What these things mean, I guess this is going to be the output to the Braille device. Yeah, so we got a write, and this right here is probably the Braille. This is the hey, there we go. This is a console. So we have a console struct, right? So what does that actually look like? Hey, check that out. So this is quite interesting. Okay. The name of the console driver. So what are we all? Where are we at in this magnificent code base here? We are, we are, we're in the, okay, we're in include, but I'm trying to, well, anyway, so I guess we can look up here, Linux H console.h. Okay, well, so we're in a big include area. All right, okay. All right, cool. So essentially, this is our console strut. Let's see, let's take a look here. We got a lot of pointers up in this turkey. That's pretty cool. So we're getting a lot of good comments in here, right? We got a bunch of callback functions and whatnot. Ski. Here we got probably the name of the kind of console. All right. What else we got here? So it looks like we got a pointer to a function pointer. This looks like a function pointer. Another. All right. Let's go ahead and see. Let's take a look here. I'm going through my trusty book, and I'm going to the chapter on pointers just to verify that it's a function pointer. Using pointers, right? So, because, like I said, it's been a little while. Boop, 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 boop. Allowing them to write functions, pure such and such. Bloody, lotty, yaddy, bloody. What the doorknob say? Off with her head. Off with her head. Let me see a function declaration. Use it function. Here we go. Function pointers. So there's that section. Section 11.4 is all about the function pointer. All right. There's actually something called function decay. A function name without following parentheses decays to a pointer that it starts. Well, function decay. Syntactically, functions and function pointers are also similar to arrays in that declarations and a function and as function parameters. Okay, so what do we got? So we got here blah 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 blah. blah, 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 blah. Which of the semantically equivalent ways of writing the function declaration is more readable could certainly be the subject of more debate. The second version, blah 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 blah. Oh, okay. So this is pretty cool. Okay, right, right. So now basically they're going through different unfortunately I guess I don't have the book. Um I don't have the book here on this machine, but essentially yes, in that section they go over function pointers and they go over different ways of actually defining said function pointer. All right. So based on that, yeah, I mean these look like simple version of a function, blah blah blah. There you go. We got a function, so they're showing you different functions. And then so no use inline, we always use the function pointer. Okay, cool. Okay, so that's interesting. Function pointer. Okay. All right. Like I said, it's been a little while since I've actually done the whole function pointer thingamabobber, but hey, looks like, yeah, the brain actually does still work. So yeah, so we got several of those wonderful items, followed by different flags and all that wonderful stuff, and then we got a couple of comments here discussing this one in particular, callbacks. So I know function pointers you use a hell of, yeah, they're used for callbacks. So essentially what you can do is you pass in pass in a ref to pass in some function pointer into a function or a particular area, and yeah, used for callbacks, right? So you're going to do a callback with that. And that's the beauty of function pointers, man. It's beautiful, wonderful, yummy thing, right? So so you got quite a few of those, and so you got, yeah, I mean it makes sense, right? So for different consoles and whatnot, ski. So you got atomic, so most likely used in some sort of threaded probably handle some sort of threading and whatnot. All right, so you got a bunch of other wonderful items here that are all atomic. All right, here you got print buffers, task struct, and of course we can navigate around all these structs to see and just continuously dig deeper and deeper into these things to see what's going on, man. But now let's go back. So anyway, so we got the Braille console, like I said. So yeah, that is a very, very interesting little thing, somewhat ski. Hmm. So we're just taking a pointer to this, right? This strut here, which is a VC data. They love struts apparently in Linux. Well, it makes sense, right? You got to structure your data, give it wonderful bounds and all that kind of stuff. Okay, so this is a nice piece of documentation right here. You know, wonderfully graphed out for you. Nice display. Discusses, all right, VC data of a console that was scrolled. Scrolled, hmm, 3 lines down. Okay, well, look at that. Okay, scroll back area, visible. Okay, so that's interesting. So I guess this is that like a virtual console, VC. So maybe if we go all the way up here, let's tell us a little bit more. What do you got here? Data structure describing single virtual console except for data. Okay, so I was right. Well, okay, so I guess this is like when you're scrolling in the console. This is interesting. So this is a mechanism. It seems like I'm just guessing based on based on the what we're seeing here in the comments, right? So yeah, so that's interesting. So it's a data structure describing virtual. So I assume basically like in internals. I'm assuming this is for consoles, internals, and whatnot, whatever, something like that to that aspect. And essentially, when you scroll down, like right now, my screen, some text is down here, and I scroll up, so now it's not there. So this virtually, maybe it handles that. I don't know. I don't really know. I'm guessing here. But that's interesting that we found that code area and it's handled that way. But I assume you have to handle it in some way. Something has to manage that off-screen area, right? So we got a state. State has X, Y coordinates, right? Color, character set that's probably being used associated with that. Intensity, virtual console intensity. Hmm. I assume italics, underline, blink, blinkety, blankety, blink, reverse. Intensity. What do we have? So that. Oh, right there. Okay, we're right there. So intensity is just an enum talking about how bright something is, normal, bold, blah blah blah. Okay, all right. Well, font, width, height, all that kind of stuff. All right. Okay. All right. And this is your virtual strut with his rather large strut there. All right. Composed of a couple of other struts. All right. There's some sort of port here. That's interesting. Couple of struts there. So now, haven't seen all these struts. I wonder which strut has the reference to the most struts. I'm probably going to write some sort of a Python program that's going to rip through here and find out which strut has the reference to the most struts and which strut has the most function pointers. All right, so that's going to be another video. So I'm going to write the program. Matter of fact, this turkey probably could help me write it right now. All right, so we might even just do that, man. I don't know. Let's see. Anyway, so that's kind of cool. So anyway, we looked at a console. We found out that hey, there's a Braille console, which is cool, man. So anyway, for handling Braille, right? So anyway, let's see what else we got here. All right, so that's for accessibility. Speak up. Speak up. All right, so that. Hmm, speak up. Okay, so obviously this would have to be. This has something to do with speech, I assume. Hmm, some sort of map. What does that look like? Okay. So some pre-mapped information or something like that, I guess. I assume, right? So sort of pre-mapping. Um, right, right. So you got a buffer, right? So this buffer is in speak up. So okay, so I've imagined that there's all kinds of different buffers probably implemented throughout the Linux code base. So we have a specific Linux, a specific buffer, right? That's just implemented in within this, right? This particular folder, right? So you would imagine, um, so when I say that, because you think of buffers, you think of different languages, and you think of okay, so you're thinking C++, you're thinking Java, these places where, all right, if I see a buffer, I'm probably thinking, hey, this buffer is probably apparent. And there's many kind of different buffers that, um, that basically inheritance and all that kind of good crap, right? Good stuff, object-oriented nonsense. I mean, good stuff, right? But here, so this is probably a buffer to capture information associated with maybe something that's spoken, right? Speak up, start, right? We got fairly simple function right here, right? Says these try to throttle applications by stopping the TT, right? TTY. Now, TTY, let's see what that, I think I know what that means, but let's go to the videotape and let's find out exactly what that means. Okay. TTY. Talk to you soon. Huh? Is that what that means? Let's see. Oh, there we go. Teletypewriter or type telephone. So internet slang. Okay, so you got internet slang and whatnot. So emulator, so GUI-based terminal emulator, Windows, are often referred to as. All right, cool. That's cool. Very interesting. Says device representation in Linux operating system. Every terminal on an I/O device is treated as a TTY. There we go. See that? This is the one I'm familiar with right here. Right? See? Um. Hmm. In computing, TTY is a system interface terminal, originally derived from the physical teletypewriters used with early computers. Okay. Okay, that's right. So it means teletypewriter. Okay. So I'm familiar with it in that particular context. So, which is, okay, cool. See right here. So we go right here into wink, winkopedia. Wink, wink. All right. So, right, in computing, TTY is a command in Unix operating system to print the file name of the